Good morning.
Good morning, Katja. We'll wait another minute just to make sure that everything has joined, and then we are going to start.
Good morning.
Good morning. So you can see my screen, right?
Yes.
Okay. So good morning, everyone. I'm Christina Gatsogianni from Center for Security Studies, Orkeme, you may know us, and I will host today's workshop. Melissa Latella from CMCC as the use case developer and Katia Panagidi as the technical manager are going to present you detailed walkthrough of the use case of soil erosion built within the EO4EU project. So, who we are? EO4EU is a collaborative European project comprising of 18 partners, organizations, and coordinated by the University of Athens. But what we are trying to do, we want, in more simple words, because it will be very explained by Katja next, the platform uses smart computer programs to help manage and analyze large amounts of Earth observation data. It combines cloud computing, which uses internet-based service with very powerful computer system to handle and process this kind of big, huge workloads efficiency for different purposes. This is achieved by connecting with existing major EO4EU data sources, by offering several tools and services to assess this kind of data and analyze and visualize them.
Ah no, non mi ha fatto entrare. Ok.
But what we are trying to achieve, we are trying to create a decision-making tool based on all these abilities that provides us the Earth observation data that could be beneficial for various users. EO4EU has developed innovative tools and methodologies that enable domain experts, professionals, and citizens to fully harness all these advantages that of the EO4EU data for informed decision-making. Our goal is to improve access and explore EO4EU data, thereby supporting sectors such as articular, environmental monitoring, and urban development. So the platform has been designed to support a diverse range of stakeholders by offering both user-friendly tools and advanced technical services. Non-technical users, such as citizens and public organizations, can easily explore and interpret data without prior technical experience. Meanwhile, policymakers, scientists, environmental agencies, and industry stakeholders can leverage the platform to gain valuable insights for environmental policies, urban planning, as we said, disaster management, and climate resilience. The platform at the same time can enable environmental, climate, and disaster management agencies to, as well as we can see, industry and business stakeholders to monitor real-time environmental conditions and natural events effectively, facilitating proactive decision-making and response. So we have 7 use cases in multiple sectors, and today we will focus on use case 5 in soil erosion. Sorry. We have 7 and we are on use case 5 for soil erosion. So delve into more on the objectives in the agenda of today's meeting. We will first, of course, Melissa will explain you the main goals of the use case and examine the significance of the Earth observation data in the fields of soil erosion and generally related fields. Then next, Katja will give you an overview of the platform, its capabilities. And following, Melissa will explain how this machine learning algorithms has created behind the use case, were developed, and how they're integrated in the EO4EU platform. Of course, there will be opportunities for questions throughout the session, and we allocate finally 30 minutes at the end of hands-on testing within the platform. Since our audience is mixed, we have both technicals and non-technicals, we will try to explain everything as simply as we can. If you don't understand something, please don't hesitate to ask us between the session, even within the chat, or you can raise your hands. We are more happy to provide more explanations about the whole process of the soil erosion. Thank you so much. So I will give the floor to Melissa to begin.
Okay, I will share my screen. 1 second. Okay, I think, do you see my presentation?
Yes.
Okay, perfect. So I can start. So good morning to everyone, and thank you for attending this webinar. As Christina mentioned, I will explain a little bit the background about the use case on soil erosion and why we decided to use Earth observation data to improve it. So starting from the very beginning, why we were interested in soil erosion? Well, most than half of the territory of the European Union is affected by one or more soil degradation processes, among which soil erosion by water. Soil erosion is a natural geological process in theory, and it's balanced over the long term. However, anthropogenic activities can lead to unbalanced rates of soil loss. And for instance, it has been assessed that more than 1/4 of European Europe territory is already suffering from unsustainable rates of soil loss. So it's a very big issue. And soil erosion induces on-site effects. For instance, it reduces the crop yield and the agricultural productivity in general, and also off-site effects. For instance, it deteriorates water quality in the river network. Also, soil erosion overlaps with other degradation processes and interacts with vegetation dynamics, as we will see better later. And also it interacts with climate change through very complex feedback. And it has been assessed that generally the trend is that climate change will exacerbate soil erosion in already vulnerable areas. So in addition to ecological effect, soil erosion has very high social economical impacts. And here you can see some example of the cost for the European Union due to soil erosion. As you can see, for instance, the loss in agricultural productivity on ecosystem services is very, very high. And all these impacts of soil erosion, ecological, economical, and social, have raised the interest of policies. And so soil erosion related indicators have started to be included into policy to track the progress towards sustainable management of soil. For instance, soil erosion is an indicator within the EU mission A Soil Deal for Europe, within the soil monitoring law, and also within the common agricultural policy. Also, at the EU level, soil erosion by water, the indicator by Eurostat, is used as a proxy to track the progress towards UN indicators about land degradation. So it's very important. Focusing a bit more about the assessment of soil erosion at the EU level, as I mentioned, Eurostat provides an indicator, 15.50, which is called estimated soil erosion by water. And this indicator can be graded according to the Eurostat scoring system. And if you look at the state of the art of this indicator in this table, we can see that some features are already good, but the other features might be improved. For instance, the indicator so far is very good regarding geographical features because it covers all the Europe and allows comparison across different areas. but it's not so good if we look at the temporal features. For instance, it's aperiodic, and so far only few points in time have been provided, and so also the comparability over time is hampered. Also, this indicator is very bad, graded as low, if we consider the timeliness, which is the speed of delivery of the product, because in this case it's, I think, 3 years, so it's very a long time, and so it's how to say, it's information that might be very useful, but with this delay risks not to be so effective to be an impact to have an impact in policy making and land planning. So in this project, we decided to address all these features and to improve the features that still have a low score by using Earth observation data. In particular, we focus on Sentinel-2 data because it's the freely available highest spatiotemporal resolution dataset. But the workflow we present can be translated also to other Earth observation data, for instance, Landsat that has a longer temporal coverage. The use of Earth observation data allows us to improve, for instance, the issue of the frequency of dissemination, because we can shift from aperiodic assessment to periodical, since the images of Sentinel-2 have a 5 days revisit time on average. Also, the timeliness can be improved a lot, because we can pass from 3 years a few days, because the Sentinel images are released after a few days and the computational efforts are not so long. And also we can maintain the high score on a reference area and comparability, because the Sentinel-2 has a global coverage and a very good spatial resolution, the meters. And also we can improve the comparability over time, because from 2017 onwards we have data. And if you want to go back, we can use other satellite data. So this was the background, and here you can see a summary of this use case. So the issue was trying to improve the soil loss monitoring that so far is aperiodic and requires different data. And the objective was to try to use Earth observation, but also artificial intelligence integrated with other data sets, and try to provide valuable input to erosion models. And this way we can address all the features I showed before. Also, in this project, we want to take a step forward with respect to the state-of-the-art assessment, also including reinforced scenarios and the impact of transport infrastructures, in order to allow users to perform a scenario-based simulation. And our main stakeholders for this project is Italfer, and the study site comprises 5 administrative regions in South Italy. And you can see here in this figure that the area we chose is severely affected by soil loss rates according to 2015 assessments. And also it's an area where several infrastructure projects are ongoing on plan. So we thought it might be of interest for the stakeholders. So the expected output of this use case are several. Among these, we thought that for the users might be very interesting to have online visualization options, and also the possibility of downloading the generated data, and also the use of this downloaded data on GIS programs in order to handle or process them again. So the expected users impacted sectors are several. I come from the research sector, so my first idea was to support the research and academia in improving the research about soil erosion and land degradations and their feedback with other system components. But this service actually can also benefit the transport sector, because you can assess the impact of infrastructures on erosion, and vice versa, the areas where infrastructure might be hampered by high level of soil erosion. Similarly, also the insurance sectors can benefit from it, because it can perform hazard scenarios, and similarly the agricultural sector. In this case, the use case might be very useful in detect areas and periods associated with the maximum vulnerability, and also decide which management practice it's better to assign to a certain area. And also this information can be useful for policymakers or citizens. So that's all, and now my colleague Katia will provide a platform overview.
Hello, thank you, Farah. Thank you, Melissa. Thank you, Christina. Let me share also my screen. No. Wait. Okay. Do you see my screen? Yes. Thank you all. So what I would like to present today is EO4EU and our platform and what is provided through EO4EU platform. As Christina said, EO4EU project is an innovation project coming from a European Union. And what I would like to keep in your mind is EO4EU platform wants to facilitate the retrieving, the processing, and the delivery of the Earth observation datasets. We know, and our main challenge is about how all these data sources are spread around different services. And what we would like to do here for you is to provide and to facilitate the services to the end users. So what are our main pillars? You can think about as EO4EU platform as a one-stop shop that you can enter in a platform and you can find data sources coming either from Galileo or from Sentinel 1, 2, 3 or from Destiny. You can retrieve this data and you can process either with the tools provided through the platform or through your own, if you can say, code, coming as a Jupyter node. We connect, as we said, the Earth observation data. We are having a mail and we leverage with cloud computing because our infrastructure creates dynamic clusters in order to use it and to facilitate your processing. We know that many machine learning algorithms need a lot of resources. We are discussing about petabytes that can be downloaded in our platform, and this can be processed through 1, 2, 3 days of big clusters. And at the end, you can leverage the possibilities and the functionalities of virtual reality and augmented reality. So all these things is EO4EU platform. What are the challenges? Of course, when we were trying to facilitate and to work to facilitate this process, we can find many diverse sources of information. Even now, the data providers change sometimes the APIs. We have different structure format of all these data sources, so it was quite difficult to find a unique, if you can say, representation and to provide this to the users. Data fragmentation, as I said, of course, the difficulty to find them and to retrieve them through different, if you can say, accounts, user accounts, APIs, different ways, and of course, lack of tools to download and process Earth observation data, because as we said, of course, we can find them. Then the volume of this data, as are in the category of the big data, can be quite difficult for a user to process it through its own computer. So this is going to be the technical, if you can say, EO4EU architecture. What I would like to think about, we are having in the left part, what is the Earth observation data and how we process them through a knowledge graph. We are having the machine learning and the fusion in order to make easier for the user to process the data. For example, we have in the merge rasters in order to merge rasters in the same time and space. Of course, all the other classes that I don't want to explain because it's a lot of hard work in order to create and dynamically process all the data and access it to the users. And at the end, at the right part, you can see how, if you can say, functionalities through the platform is the front end. You can process it through a workflow editor, the OpenEO compatibility API, and of course, a user management service. So these are the main, if you can say, ties that I want to keep in your mind. So why a user to use EO4EU? As I said, it's a one-stop shop for data sources. No one is need for changes in the APIs, and we are having a common space in order to retrieve data. Then we are having infrastructure. These infrastructure resources are provided to the users dynamically in order to process the data and not to be processed in their own computer. Machine learning and fusion models provided as a toolbox, of course, with the help of use case leaders as Melissa that we have provided. And of course, you can create your own notebook in order to process with your own way all the data and to test and also to test your functionalities through our platform. And the visualization, augmented reality and virtual reality technology. So an example, a user enters to the platform, what he can do, he can search data and he can select different data in order to integrate it through a process. We can select, for example, data from the Sentinel, Sentinel-1 or Sentinel-2, and of course we can select also from ERA5. Then you can create a workflow in order to process, to download data, to visualize data, and to process through specific, if you can say, machine learning algorithms provided through the project. Start the workflow, get the results, and the visualization. Another thing is he would like also to integrate this data with his own dataset. So you can upload your datasets as in situ data in the knowledge graph. You create the same workflow, you use predefined functions, and you get the results and the visualization. A third thing is you don't only want to upload your own data, but you also to use your own functionalities because you are a user that is expert to the data processing and the space processing. You are not, if you can say, you would like to go further of the functionalities provided in the platform, so you can also use it through function as a service provided in the EO4EU. And of course, you can save this workflow. When we're meaning workflow, is an action of steps. Melissa will show you, for example, but it is a drag and drop sequence of action of what you would like to do or what you would like to be executed in the EO4EU platform afterwards in the backend. And at the end, another thing is that if you are having a workflow and you want to rerun it, why? Because it's a cron job. It's something that it is timely, it is daily. And we are having services that they don't want to go through the graphical user interface of EO4EU. However, they would like to download data daily, process them, and provide something to a user or to a service. Also, this is possible in order EO4EU now is a black box. You are calling this API again and again, and you are having your output of this algorithm. So here is a representation of the dashboard that we're going also to show you. The main web interface has, if you can say, some specific components. We are having the datasets, the dataset sets. We are having the workflow creator, the editor. We are going to see what is that. And then we are having data visualization, map visualization, and the file explorer. Why data visualization and map visualization is different? Because it's different the nature of these files. Data visualization, we are discussing about raw data, numbers, if we can say that you can figure in a specific graph. Map visualization is geospatial images that you want to demonstrate it on top of a map. So it's different types of visualization, so it is needed to have a different, if you can say, interface. Knowledge graph is the common, if you can say, space that you can search through keywords and queries a specific dataset. You can search based on selected sources, and then you are having also features that you can select. For example, a specific area, a specific time zone that you would like, and then you can select what data you want to save. Building processing is what is the workflow creator. What we say as a workflow is a chain of actions. When we are talking about data source, we are meaning the downloading of data in a specific space, in specific files. OpenFast is, for example, an action that you want to upload your own code. And the data output is where you want to save your data. And then we can have also customer face in order to use the graphical user interface of EO4EU to demonstrate data, or to use AI, ARXR. This is, for example, in another use case, a sequence of actions. Data visualization, as I said, is when we're talking about data, we are talking about numbers and figures. What we would like to visualize, for example, is graphs. You can see it as a specific graph or as specific numbers. Map visualization or AR visualization right now, XR is on top of a map. This is also provided in our platform for geospatial images, that we are creating digital elevation models on demand for the specific area that you have selected, and all the TIFFs or the JPEGs are demonstrated in a common AR interface. Here, I'm having also a video of VR representation through the Meta glasses that you can go through an API provided through the EO4EU platform on the glasses. You can select the workflow. I don't want to waste your time. You can select a specific workflow and the results of the workflow that you have created. And these results can be demonstrated in space. You can check them from above. You can go on your own desk. You can grab them. You can see in more details about this. You can zoom in, zoom out. But you can also, this information can provide it real time in your palm, if this is a description that I can make. Here is it, for example, a fire risk probability. In real time, you can see through weather and temperature and the soil representation, how is the fire risk of a specific area. So this is the augmented reality and also the use case. And of course, it is provided also through a mobile application that every TIFF can be augmented and can be represented for a user in a specific, if you can say, in an area or through a mobile application as augmented reality. However, data, as you understand, many of data that we have here as an example are not in the scale of a house. We are talking about on a scale of a city or through a bigger scale. So this is the zoom in is quite difficult, but this is also a representation and a use of augmented reality with Android application. And with that, I would like to thank you. And if you have any questions.
Is there any question for Katja, for the platform? No, currently. So we can continue with Melissa.
Okay, so we share again. Okay, so. Okay. In this second part of my presentation, I will show some detail about the development of the use case, and then I will provide a practical example on the dashboard that Katja has just shown. So The underlying methodology of this use case recalls the EU standard. So it's based on an empirical model, which is very commonly used worldwide, and it's called RUSL, Revised Universal Soil Loss Equation. This model is composed by a single empirical equation that you can see here, and basically it provides the potential longer-term soil loss as a multiplication of 5 factors. The first factor, the rainfall erosivity, represents the driving force of the erosion process. And the other factors can be grouped into the terms soil susceptibility and describes the overall vulnerability to erosion of the land. So they describe the land response to erosion. And they are the LS, slope and length stiffness factor, which represent the morphological features of the terrain and how they impact on soil erosion. And the second is the soil erodibility, K factor, that represents how textural and chemical properties of the soil can influence the erosion process. Then we have the C factor, the land cover management, and I will talk a little bit better later. And then we have the support practice factor that represents the inhibition of erosion due to man-made artificial barriers like terraces or stone walls. For all these factors, we perform a literature analysis, and also we interact with stakeholders in synergy with other projects on this topic. Collecting all the feedback and our research on the literature, we found out that each of these factors presents some gaps in the computation. In particular, regarding the rainfall erosivity, we saw that rainfall patterns are changing, so the static behavior of these factors needs to be adjusted according to future projection. So basically, the future rainfall erosivity might differ a lot in comparison to the current one. The second factors we will focus on is the slope length and stiffness, so the morphological one, because we saw that in the literature there are already state-of-the-art methodologies for the computation, but this computation generally includes only the bare ground and does not include the territorial features like transport infrastructures or other barriers that can alter the dynamics of sediment movement. Finally, we saw that the most critical factors was the C factor, the land cover management, because this factor describes the influence of vegetation and its features on the erosion process, and generally is assessed at an annual or multi-annual scale, while vegetation has a subannual seasonal dynamics. And so we saw that the stakeholders ask for increasing temporal dynamics and spatial granularity. And so these 3 factors will be the objective of this use case. In the service, at the end of the project, you will see the entire computation. And of course, we have to handle also the other factors. And basically, you will see that on the EO4EU platform, there will be data sets for the factors here in dashed red line. And this factor will be computed with the consolidated methods with some modifications, for instance, for the LS factor. And the data sets are now ready off the platform and will be deployed very, very soon. And in particular, for the R factor, we computed it considering current and projected scenarios for obtaining 3 different data sets. For the LS factor, we perform a computation following the state-of-the-art models, and also we added a computation with a new model to account for transport infrastructure. So we will upload on the platform 2 different data sets. And finally, the K factor was computed following an empirical model based on soil grids data. And for the C factor, I will explain in a bit the computation methodology based on artificial intelligence. And finally, the 5th factor, the support practice, was not considered in this project because generally is negligible when the other factors are improved, and also it's often set arbitrarily. So for a conservative behavior, it's better not to include it. So diving a little bit in the detail of the C factor, I told that it's a very important, maybe the most important factor for soil erosion. And this is why it's a very dynamical factors. As you can see in these images, the land cover management can change a lot in space and time. Indeed, you have to consider that, for instance, where vegetation is very dense, the erosion is inhibited, and where there is bare soil, the erosion is very high. And as you can see in this figure, for instance, the transition can be very sharp. Also, there can be dynamic in time. For instance, if you consider a cropland, you will see that during the year there are several variations in the vulnerability related to the vegetation cover. For instance, during the growth phase or at the end of the growing season, the protection to the soil is very high. And after harvesting, for instance, we have a bare soil, and so the protection becomes very low and the soil is very vulnerable. So for an effective assessment of soil erosion, accounting for the spatial and time dynamics is very, very important. And we try to include it in this project by using satellite products. Why we decided to use satellite products? Well, we look at the state of the art of the computation of the C factor, and we found out that there were several methods for computing it. And but basically for performing large scale assessments we are interested in, the computation methods were basically two. The first one is based on using land cover and land use maps. And the C factor in this case is assigned based on a lookup table and considering the land cover and land use classes. And here you can see an example from a sister project of EO4EU, which is SDGIs. And in this case, you can see an example. We have a land cover map, and we assign specific C factor values based on the land cover classes. For instance, we assign very low C factor where you have forest in the dark green areas, because forests protect a lot of the soil. And then we assign higher C factor, meaning higher vulnerability maybe in croplands, because we have to account for the seasonal variation. So this is an example. And obviously, as you can see, this method is very simple. You are not required to have a specific expertise to apply it, but it has several negative aspects. For instance, we have to consider that the land cover data are generally have a very coarse resolution and are not updated periodically. For instance, the Korean land cover dataset, which is the most common one, it's updated every 3 or 4 years. So we don't have annual or sub-annual information that we want. Also, they have some sources of uncertainty that's added to the uncertainty related to the lookup table. Another approach that we found more interesting for our application was the calculation of the C factor based on satellite products. Basically, you assign the C factor based on relationships between the C values and spectral indices. For instance, the NDVI, but I think you know, it's the normalized different vegetation index, and it's very widely used to assess vegetation status. And this method is very common. A recent review highlighted that more than half of the works are based on this. And in this image, you can see some example of the benefit of this approach. For instance, you can see that for the same area, I forgot to say it's the Olte River Basin in Romania. For the same area, this approach can allow to perform both annual comparison. For instance, here you can see the comparison between 2018 and 2022. And in this case, we highlight a very high increase of the C factor in this area due to deforestation. And also it allows to perform sub-annual analysis. And here you can see the winter, spring, summer and fall assessment for the same area. And this information is very important for land planner and managers, because it allows to understand which area are more vulnerable in which period of the year. And the results indeed are very different from the annual average. Other positive aspects of this approach are related to the fact that we are using satellite images. So as I mentioned at the beginning, the timeliness is improved and the spatial resolution is generally very good. So you might think, okay, just apply this approach. Well, the issue is that there are some weaknesses related to the use of the spectral features. Generally, this model relies on a linear relationships or some relationships with a single spectral index, but every spectral index, for instance, NDVI, has some drawbacks. For instance, NDVI does not work very well in very highly densely forest or in an arid area. So its use must be carefully examined. And also we saw in the literature that there is a strong disagreement among different formulations, as you can see in these graphs. So we decided to build from this solution and provide a new one in the EO4EU project. So first, we decided to account for plant phenology and subannual consideration by using the Copernicus products, so Sentinel-2, as I said before. But we are not using a single relationships, but we set up a machine learning method to assign the C-factor directly, leveraging all the properties of the Sentinel-2 images, and also training this model based on field observation in order to improve the reliability as much as possible. In this way, we are trying to address the current weaknesses of the methodologies. So now I will show the workflow behind the machine learning method for the C-factor, but I will introduce it by just explaining the underlying idea. The idea was to generate a lookup table for each plant growing season stage. Growing stage, for instance, start of a growing season, middle and end of the season, and then create samples of satellite images for each land cover time and different season in order to have a very wide data set to use to train and validate the machine learning algorithm. So here is the workflow. I hope that now it's a little bit more clear after having defined the underlying assumption. So as I just mentioned, we started creating a lookup table based on literature values, but also based on the season, and also based on the Lucas data sheet. The Lucas is a very wide survey across Europe, and that provide information on the land cover. And we started from that to we take the Lucas point and we start from that to generate our sample. The second step is generate the sample. As I mentioned, we took the Lucas point for 2018 and 2022, and we clipped the Sentinel-2 data, so the images across these points, and we assigned the value of the C-factor thanks to the lookup table we just built. Then we use all these samples to train artificial neural network algorithms. We test a lot of different algorithms. So we test the different bands and different combinations in order to find the most relevant one. And then we completed the training and the validation. And all these operations were carried out offline, of course. So in the platform, you will not see anything of this. And then we deployed the algorithm on the platform, where the challenge was to connect the trained models, to the Copernicus provided Sentinel-2 data for the area and the data of interest of the user. So this is the only part you will see. So the area selection, time selection from the user, and then the output from the algorithm. Here are some details about the machine learning development. We'll skip a bit, and then if you are interested, you can ask me more in the Q&A session. Basically, we train very different, a lot of artificial neural network models, and then we select the most performing one, both in terms of performance and in terms of computation time. Interestingly, we inform the algorithm with a lot of features, some of them deriving from the bands of the Sentinel-2 images or from their combination, so the spectral index I talked before, and also a nonlinear combination in order to detect nonlinear relationships in the physical process. And then after the training, the model was able to select only the most relevant of these features, and this might be very important results to understand better the physics behind the process. And in total, we used more than 160,000 locations across Europe based on the Lucas datasets. And for each location, we created 52 samples accounting for each week of the year. So this is a huge work, and the refinements are still ongoing. Okay, so now to see how this algorithm is embedded within the overall workflow of the soil erosion assessment. Here in this box, you can have a recall of the underlying model, and you will see that the workflow is very simple because the underlying model is very simple. So starting from the very beginning, for the soil erodibility factor, the K factor, we just provided a data set on the platform, highlighted by the blue color. For the rainfall erosivity factor, the users can select the scenarios, so current scenarios or two different projected scenarios in orange. And then the algorithm in gray take the information about the user selection and select one of the data sets available on the platform. For the LS, so the morphological factor is very similar. The users can select if they want to account for infrastructures or no. And the model will select the pertinent data set here in blue. Finally, here you can see how our machine learning is embedded. The user can select the time range and the area of interest, and the algorithm will do the rest. So it will collect the Sentinel-2 bands, and it will compute the C factor, and it will provide the newly computed data sets that you can see in green because it's newly computed. And obviously one input of this is our train model. Then after having all the data sets corresponding to the factors of the Russell model, the algorithms perform some reprojection in order to align them, check the reference system, clips everything on the area of interest, match the resolution, and then multiplies everything in order to obtain the soil loss, which is a newly computed output in green. So in my example, we'll talk in the demonstration, I will talk only on the C factor, but I want just to provide an overview of what's already ready offline and will be deployed online after summer. So we prepare the data sets to be uploaded, in particular the rainfall erosivity for different climate scenarios. I know that the difference cannot very be appreciated at this scale. And then we prepare also the soil erodibility factor data sets and two data sets for the slope length and steepness with and without transport infrastructures. And today, as I mentioned, we'll only see in the demonstration this part of the workflow. So the user selection, then the construction of the workflow, and then the deploy, the calculation of the C factor. So now we will start with the demonstration. Just give some information in order to try to be as clearer as possible. The area you can select for the demonstration is anywhere within South Italy, and the time you can select any time according to the Sentinel-2 coverage, and Sentinel-2 starts from 2017. And you can select any duration from a minimum of 1 week to account for the revisit time of the Sentinel-2 data, up to the world data availability. Of course, in the example, we will take a very short period because the larger the area or the period, the longer the computation. And And also the choice of the period depends on your purpose. If you want to see annual average, you can take 1 year. If you want to see maybe seasonal trends, you can select a shorter period. And the method we will show today is the C-factor computation. Sorry, I tell thousands of times. And based on a prototype of the shown algorithm, because it's only based on the RGB bands in order to speed up this demonstration. But soon you will see the complete workflow updated. And the steps we will take together now will be the data selection, the creation of the workflow, the editing and running, and then the results visualization. So I will go to the platform. Okay, so this is what you see after the login in the platform. And you can see several options. And now I will show how to compute the C-factor. But if you want to replicate this and you don't remember any steps, don't worry, because in this panel you can also select the user guide that provides information on the general functionality of the platform, and also it provides tutorials for the use case. For instance, here you can find a tutorial for the use case 5. So let's start. For this use case, we start from the data selection, as I mentioned in this slide. So data selection, you can perform this in the dataset search. And as you can see in the guidelines, the data we are looking at on the ADAM platform, and we are looking for Sentinel-2. So you can type it, and then you can search. And in this case, we need the 3 bands, as I said, the 2, the 3, and the 4, corresponding to R, red, G, green, and blue, B. So we look, it's on the other page, I think. Okay, so we have Sentinel-2, L2A. L2A is the level of processing, and this is the most refined process data from Sentinel, and band 2. So we select it, and if you want, you can read the whole description of the dataset, and you can inspect the format, and then you can perform your user choice. So select the area of interest and the period. Interesting, you can draw your own area of interest. For instance, you want to select this small area here. I do it very small, so it will be quicker. And then you can go down and pick a time range of interest. You can click and have in a calendar, or you can just type. For instance, if I type and click enter, the time range is selected. And then you can filter. So in this moment, the platform is filtering the catalog in order to find the Sentinel-2 images that are covering this area in this period. Might take some seconds. Maybe more than some seconds. Sorry. Okay, completed. So you can select all these images. I advise you to count how many are there in order to check issues with the dataset selection in the next step. So in this case, we have 5 images. Then you can select true, which is a way the algorithm combines information. And then you can generate the script. This is very interesting because now we are seeing how to use a user interface, so this dashboard, but actually you can also copy this image, this code, and use in Python terminal in order to perform the run of the code. But we are not interested in this moment, so we just save the data set, and we can see that the data set has been added to our list. And you can repeat this. This step for all the other bands. So in this case, we need RGB, so also the band 3 and 4. So here is the 3. And of course, for the function of the algorithm, you need to select exactly the same area and the same time interval. And this is facilitated by the fact that the platform memorize your selection. So if you click like this, you will have this is the last one here. Okay, you will see our latest selection, which is here. So you're sure not to be to select the wrong areas. And then you can select the time range of this one, and you can repeat the filter. Okay. Now it's doing the same as before. So you can select the dataset you found and generate the script. But what happens later? So I will skip to the second point. After you finish, selecting the datasets, you can go back and go into the menu for Workflow Creator. In the Workflow Creator, you see all the datasets that you selected before, and you can decide which one you want to use for the workflow. In this case, I want to select band 2, 3, and 4. Then you can give a name to the workflow. You have to give a name to the workflow. Test, today is the 14th. Okay. And then you can create the workflow. So in this part of the dashboard, you only need to define the workflow name and the input data. Okay. After this, you can go to the workflow editor. So if we look at the steps I mentioned before, we just created the workflow, and now we are going to do the editing and running. So this is the one I created before. If you want, you can also inspect the previous one if you have. And if you click the three dots, you can open it, view, and you can create your workflow. So in this case, and you will see also the user guide, the workflow is quite simple because we have some data sources, which are the data we selected before. Then we need a function to merge all this information because we selected 3 different bands from Sentinel-2, but then the algorithm works on the ensemble of these bands. And then we need to apply the train algorithm. And inside this box, there's everything I explained so far about the artificial neural network algorithm. And then after this, we can just produce the output and select also how to visualize it. For instance, artificial AR XR, or the customer face that means maps and data graphs. So after selecting the steps we want in our workflow, we can just connect them with arrows. If it's difficult, you can zoom a bit. Okay. And these arrows are important because they give a direction to the algorithm. Okay, and this part is very important because in this case I'm showing just this application for the C-factor and the soil erosion, but actually you can play as you want by combining data and functions in order to provide maybe other kinds of results that might be useful in your work on your research. And after this, we are sure about our workflow shape. We can save it, and then we can publish. It's compiled, and now it's publishing. So we can go back to the home. And now the workflow is running, and if you want, we can view it, and we can see if we can go, we can see the status. Now it's still in the publishing state, status, so we cannot see anything. But if you go, for instance, to a previous workflow I did, we can see the update. So in this case, it was finished. So the data source was finished, this step was finished, etc. So you are informed about the status. Okay, now it will take a while to compute, maybe some minutes, so we can skip to the results by using one of the previous workflow I created in the last days. You have several ways to visualize data. Just for information, you can also, it's not the case of this data set because it's a map. So we are not interested in a chart, but eventually you can select your results and you can create a chart if you are interested. For instance, you can create a line, bar, scatter plot, etc. Also, you can visualize on the map. For instance, we can use this. And you can see the C factor on the map. Okay. Then, oops, zoom out. Okay, but let's go to the other. And finally, you can, no, not finally, almost finally, you can also select the data you want to download, because maybe you are satisfied by the online visualization, but you want to modify your data in your GIS, or maybe you want to use it for other calculation with local data. And so you can select it. You can select the workflow you are interested. You can look for the data or for the results. In this case, I want to download the results. So you can go to C factor. And you can download the data you prefer. I want to visualize it on GIS, so I select the TIFF data. Then right bottom on the mouse, and then I can download the file. Okay, so, and for instance, once it's downloaded, you can use it to visualize. This is our results visualized in a GIS environment. Finally, Katia showed before the three-dimensional visualization of results. You can do something similar also for this use case. For instance, always taking this example. You can look for your data. And you see it's here. You can click it. And you can visualize in a three-dimensional way. This is the input data, so the band 1, you have the three bands we used, and you can also visualize the results. So this is all. I hope it was clear enough, but I am open to answer your questions if you have any.
So are there any questions from your side about Melissa's detailed presentation about the soil erosion for the machine learning algorithm, or for the testing within the platform? Some details. You can raise your hand or you can write in the chat. Okay, that sounds good. They don't have, because it was a very, very detailed presentation from both of you. So, and you, Melissa, thank you. It was, yes.
Yeah, yes, I hope it was clear enough. But as I mentioned, there's also the guideline, user guide on the platform. So if you want to replicate, you can use this.
Yes. So since there are no more questions, I think that we can continue to maybe to the hands-on session. Since on the same time we have left time for this for the workflow that Melissa have created, because it needs about 20 minutes. How much time? The workflow that you have created currently until we see the final results.
Yeah, it takes, I don't know if 20, but something similar. Yeah.
Okay. This is how something is connected with the huge size of the data that we are using. but since, as Melissa showed you, there is step-by-step, it shows we have this tab on the right of the workflow that shows you that the process is running. So Katja have shared in the chat.
Yes, I have shared in the chat the access to the platform. If the users and all the participants want right now to log in and at least to make a registration in order to help them with step-by-step at least registration in order to see what Melissa has already presented. Congratulations, Melissa. I don't know how you would like to proceed.
Yes, this sounds good we will give you some time to register into the platform. And if we would like for you to start just using to run some tests, just to see the interface and the workflow.
What I can do is to share a little bit. Wait a minute. Right now, if you're going to click in the link that I have sent in the chat, you are going to be forwarded in this page. This is the main page of login. We are secure under Keycloak. What I would like to do is to push, if you can say, to select create an account. This is going to guide you in another form. You can select, for example, your username, your names. I can take right now because I'm already having you can put your email, your and a password if you can say 1, 2, 3, 4, 1, 2, 3, 4, and you click the register button. After you have registered, you are going to be logging. You have to identify through your email about your account, and then you are going to log in the main page of EO4EU. So please, all the participants, if you like, you can make a registration. If you face, we can give you 5 minutes in order, if you face any problems, we can resolve it together. We are here for, if you can save your time and to facilitate your first time in your For You platform. The floor is yours, Christina.
Yes, I was trying to say that we will leave you a little time, 2-3 minutes. Please raise your hand, share your camera. You can share your screen, of course. This is interactive workshop. You can share your screen, whatever you want to ask us if there is any problem. So we'll give you 2-3 minutes to see if you are having trouble with registration. So they'll continue step by step with the following the hands-on session. In the meantime, of course, if there's any other question that came to you from the previous presentations, please go ahead and ask. Oh, thank you, Katja. I forgot to tell the beginning. So, did you manage to register on the platform? I know that, Katja, you said we still have the authentication tool for the new. We don't on the old ones.
No,
Okay.
we have a deactivated OTP. So that's why if you're going to register, you're going to log in afterwards in the platform. Because
Okay.
OTP was quite problematic. If you would like to run a cron job that you have to enter your OTP day by day, it will not automate the sequence.
I still have that. I have to register.
However, yes, probably, or we can contact the technical support. You shouldn't see the till now the OTP. Will have to be deactivated, but you are an old account, so probably you have to contact SMWF to update you to the new account.
We have two questions, Katja.
Yes.
About their first value contains invalid character. Maybe do we have a constraint about when registered?
I don't know about what is the containing valid character, either in the name or in the password. Usually, please avoid to have the minus and to enter the underscore, probably. Maybe it's that one, but I don't know which value. This is automated but coming from the key clock. It's like a registration. Good point. I can check with the technical support. Of course, you can make. It's in the second one. If I now having an account, will be able to use it on another day. Of course. Now you are registered users. You can select it and run a test whenever you want. Just if you can say two things that I would like to show. Wait. Tell me.
No, there is a second comment also.
I don't see.
Now about the account, someone that has already an account to the system.
You can register as well.
Yes,
we
yes,
don't
to
have...
another day. Sorry, it was I was saying something. Yes, you can register every time. It's free.
The only thing is that here you can see the dashboard. What I would like to show, if you can see my screen, is that in the left part we are having the notifications. Also because whenever a mail you want, okay, whenever you are having a machine learning, the data, it depends from the data and the volume of the data that you would like to download. Of course, we cannot provide an estimation, but here in the left, when you are going to publish, as Melissa presented, quite outstanding. Thank you, Melissa, again. You can see the components that you have selected, and when something is completed, you can see one by one. So you will know in which step you are, except from, as Melissa shows, for example, here, that I'm having also the status of, sorry, this is an old one. I'm making also a lot of tests, as you can understand, and stress test to the platform. For example, where is it here? You can also see the status as a green light, but you can also see in the left part any notifications in the specific workflow as a comment. Another thing that I would like just to have in mind is that if you are interested, I can provide you with a script that can run in a Jupyter notebook. For example, I'm running this in Colab. We are having EO4EU utils Python library, and then you can recreate the script of UC5, of all the scripts needed for UC5 for the area of Germany, and here I'm having the configuration utilities, in order to download data, to select the data automatically, to create the workflow, and then you can create the chain of action. This is a second way in order to make, if you are an expert user or a developer, to facilitate you more automatically with the command lines and some Python code. Just as an example, nothing more, nothing less. You forgot it, I just said it, I don't want to make things complicated, okay?
Yes. So have you managed everyone to to log in so that we can go to the next step in the data source in the knowledge graph, searching the bands?
Okay.
Katia, great.
Yes. One thing is, as we said, right now we are having the bands and the sources. You can see that we are having sources coming from ADS, CDS, ADAM. Usually, as Melissa said, we are having here also all descriptions of the tools, the functions. We are having a user guide right here. In the user guide, for example, you can go in the use case tutorials, select use case 5 that Melissa presented, and here are all the details. However, how we use the data set? The data set is coming, we are selecting, for example, Adam, and we can select also Sentinel-2. This is the band that we want. We want band 2, 3, and 4. Here is the band 2. In the pop-up window, you can check the descriptions, the file formats, but if it's provided by the provider, and of course we are having another advanced filter. I can select here in the right upper corner, close to delete all. You can select, if you can say, if you have already selected a source, you can replicate a selection. So when I'm going to create for Sicily, for example, a bounded box, can I replicate it in my other data sets? The answer is yes. So you can select, if you save this data set as preferred one, as we say in your card, in your favorites quoting, then you can use it. Another question, another request coming from the users was to have a manual longitude and latitude. For example, if I don't want to draw it, but I have it in my mind, I know exactly the area that I want. Can I put the 4, if you can say, elements directly in my mind? The answer is again yes. Either from here, either from drawing or from pre-selecting areas, you can make your selection in area. And you understand that the area is quite important for a user. Another thing is the dates. You can select, for example, 2025 from 1st till one quite faster. Sometimes I select it also as a keyboard. I'm pushing enter and I can select filter. So this thing is selecting the bands for UC5, where I wanted band 2, band 3, and band 4. And this is the interface from Adam. Of course, if you're going to other, if you can say, sources, the process might be a little bit different. It depends from the data providers. For example, I had a lot of days, and the area is quite big, so that's why we are have to wait. Let me show you another. That, for example, we have integrated UMIChat. UMIChat can provide, for example, NDVI results. We can see here the 10-day NDVI. Here you can see you don't select area. You select from NDVI usually from the UMIChat for Europe, one of the 3 days, 1st, 11th, and 21, month and year. And this downloads you an HCDF, if I'm not mistaken. Right now we are having 17th note. I think it's the 1st of July 2025. Generate a script. And this is also a script, save a dataset in order to use UMIChat. What I would like to point out is we are having different interfaces based on different data providers. That was the main difficulty of EO4EU. But this works. And this works pretty well. Of course, you need to have some patience. For example, here, if I'm going to select all, I don't know if he didn't find something. Okay. For 2025. Probably we can select another area. Here. I'm putting some random areas. That's why probably Sentinel does not have a specific, we can say, a data. But the process is the following. Afterwards, if you are searching the data, and I believe that you need some time for in order to play a little bit with the data search, then we're having the workflow. The workflow is something like that you select all the data sources that you have searched and saved in the data search step in order all these things to be added in a same, if you can say, chain of actions. So it's like that as in your car, right now I want to pay, for example, for Sentinel-1, Sentinel-2, Sentinel-3. So if you want, there you can select all the data sets that you want to be downloaded together and be added in a specific workflow. For example, here I'm having era 5, or Sentinel, here it is. Okay. I'm going to select it and I'm going to name it Sentinel example. Create workflow. I select, I'm putting a name, and I'm creating a workflow. And this workflow editor is going to create a draft workflow. Here, the main thing that you have to add is data source and data output. Data source means that the 3 data sets that you have already selected from the data sets are going to be downloaded automatically in the specific cluster in order to add it as a specific process. Another thing that you can do is also to add your in situ data. If you want additionally to add a shape file, an HCDF, some CSV that you would like to process together with this data, you can also do it in this step. And of course, and then you will proceed with the use case 5 or whatever use case you want to test. If you want to visualize it through the GUI and through the ARXR, just add as a workflow. The simplest workflow is the following. You download the data, and as an output, you are visualizing through the GUI, and you are having ARXR. This is the simplest workflow that you can do with all the data sources. Download them and check the output. Of course, you can have the fusion. Here in the information, of course, you can see what is the input and the output of each algorithm, what is usually the previous component and what it computes. And the same stands for machine learning, for example, for use case 5, soil erosion prediction. You can see the description of the function Which is the usual previous component that is the merge punch from fusion? What is the expected input and what is the expected output? I don't know if, of course, we're having a YouTube channel. Thank you, Pablo. I don't know if you have any other questions or if you want to create a workflow together. We understand, of course, that this is too much information to digest, of course.
Yes, we will have the guide to support this. And of course, we will enrich the guide because there are so many details that we haven't had the time to put in the guide. But we will try to enrich it with more details because Katia said so many things that still not be uploaded there. But we will try to do so because we have did so many improvements the last few months. So I think from September we will have the monolith user guide. So you can have also, you will have access to. I don't know how many of you have reached to at least run the first step, the second step, sorry, of searching and collecting the data from the knowledge graph. Did you face any trouble? It's okay? Yes. Yes, Raf? Oh, sorry. I don't know. Is there a problem? Have you managed to do that? Melissa, at the same time, can you check if the workflow that you have created has finished?
Yeah. So yeah, that's finished.
Okay.
Okay. So I will share one moment. Okay, so as you can see, the workflow has finished. We can see from here, and the dots change their color, if you remember before. So this step is completed. This one also, and the processor is finished as well. So similar to what I showed before, you can decide to visualize this data in different ways. And for instance, we can go to the workflow, the ARXR, and we can zoom across the area. And here we can click on our area of interest and see the map of the results, and you can play with them a little bit. You can zoom in and zoom out as you want. Oh, this is the band too. The band, sorry, and this is the C-factor results. I don't know why the color bar changes, but the values are the same as before. So that's all. And also in this case, if you want, you can download and then visualize on GIS and use this data as you prefer. Okay, so that's all from my side. And I understand that it was a lot of information for just one webinar. So if you have any doubts in the following days, you can write to us.
Yes, just to answer the question about where we can find the description of the algorithms for workflow 5, it is in two parts. First of all, you can the first thing is that knowing, for example, you're having an indicator, like here is the use case 2. So soil erosion, what is soil erosion C-factor prediction is about the ML. That's wrong. GeoTIFF, description, what is the input and what is the output. Of course, we're having the merge bands of the fusion. Here you can see also use case 5, it's AP2, the output, what is the previous component is the source, and that creates TIFFs from different bands and consolidated TIFFs of all three. What we are meaning is we are having band 2, band 3, band 4, and the fusion first consolidates all the TIFFs in one, all the three bands in one, and these new TIFFs are provided to the soil erosion in order to predict the C factor. That's what we are making. So the first step to see the algorithms is from here. It's in the top of the AI ML is the AI ML marketplace. The other option is when you are in the workflow creator, in the workflow editor view. On the left, you are having the possible descriptions from Fusion or from the ML. So, for example, for use case 5, it is the same. Use case 5, merge bands, and here is the description of the algorithm for use case 5, either in the Fusion, and the same stands for the ML. Oh, I can see them. Also, you can check for the other information in other algorithms.
And in the user guide, there is
Also,
the step
yes,
of the progress.
Yes, I'm sorry, Christina. In the use case 5, you can see step by step the images, and if I'm not mistaken,
yes,
we are having here, let me save image as in the downloads, just to make a zoom. That's why I would like to download it. And here you all, it's in low quality. But here you can see also the stream of the workflow actions that you have to do in order to replicate Melissa's use case 5.
So, thank you, of course, for the explanation, Katja. So, as you have seen, it takes about 50-30 minutes, 20 minutes, sorry, to run this kind of workflows. It depends on the size of the data, of course. So just pay attention, it needs some, let's say, passion for the workflow to be completed. But that happens to all these kind of platforms that combine and work with EO4EU Earth observation data because of their size. And of course, as you have seen from Elisa's presentation, you can not just download this kind of all these kind of produced maps. You can upload it in different platforms to make work, and you want to proceed them with a more, let's say, you want to work with different, let's say, tools like GIS. You want to do something more. You have the ability to upload it. They have the coordinated system, so you can proceed safely to that. Do you have managed? Yes. Yes. Maybe another question we have is
That is correct. Yeah. What I would like to show, it is the question. In the fusion and the ML algorithms, yes, we cannot change, you can say, the input, the algorithm by itself. It's something like a black boxes that will help the user just to replicate and reuse it in his own way. If a user is quite expert, he would like to add his own source or his own scripts, what we can do is you can add, of course, data source, data output. This is what we are saying for as essentials for the visualization probably and as an input. However, the data output is also okay. And what you can use in the fusion part is the, where is it? No, in the static, the fast. The fast component is the following. If you are double click it, you can see either to write a Python script here, you can add your own Python, you can run your own Python script, and of course you add the requirements of your script. We are going to add in, because it is in the development environment, we are going to add after the workshop cycle in 10 days, I believe, the notebook part, that you can upload also your own Jupyter notebook with just the requirements of, yes, of course. You can add also the Python script and the requirements in the library. Of course, you can. We're going to also to upload the notebook and the Jupyter. What I can say is the following: you can always contact us in this email in the technical team EO4EU. And of course, we are a team of all the components. So if we are for workflows of a technical team, I'm going to answer probably as Kate Panagidi. From the mail perspective, and if you want to ask something about the mail, Pablo Strasser, that is already here, is going also to answer. For visualizations, people from EBOS, or if we want it also from NKUA, we're going to support you with Python code and your Python script on Jupyter notebooks.
Thank you so much. Are there any questions in the meantime that you may? You need more explanation? Okay, is there somebody that could find is there have you managed to go to in the step of creating the workflow? Are there any questions there? We try to leave you an estimation of time until you do that. So I will leave you a few more minutes. If there isn't a problem with the creation of the workflow, you can share your screen. We can answer directly on the workflow there you're creating. Katja, I think you have a question. tailored for you.
Yeah, no. What we can do is the following. We don't have an automatic mechanism in order to integrate, for example, with Google Earth Engine. What we support is to download the data from the Google Earth, to upload it as in situ data, and then use all our platform, all the functions and all the ML in our platform. Or probably you can also, probably also we can also use it as a notebook in order to download as in situ, for example, and to be checked inside the notebook, something like that. That's what I'm thinking.
So have you checked, maybe some of you have been already in the process of creating a workflow. I think we can leave for 5 more minutes for the session open, just to make sure that if you have some more questions, since you are maybe since you are testing the platform at the same time, as the system is running, we are going to provide you a certification for participation for this workshop. And of course, because some of you have interested in, as you can see from our website, we have more workshops that are going on. We will provide you, for those that you have interested in more use cases, one that contains every use case. But if you want something different from us, please don't hesitate to contact us. You have my mail from the mails that I sent you these last few days. And of course, you can connect with EO4. For some of you, you can always contact us through our website. We have a contact, let's say, form there. And what we would like also from you is that we are going to share with you a questionnaire in the following days about the platform, how to use the platform, so that this can provide us a very, very, very concrete feedback of our work, of generally of the platform and for the use case itself. And it will be very beneficial for us if you could provide us feedback about this. Thank you. I think that is a question about the public, if we are going to allow public machine learning, right? Yes. Ah, sorry, Pablo, you wrote that. Sorry. No, sorry. No, sorry. And I was going to ask you. Okay, sorry. Yes, we can. We have to. We'll update the page, the website, about this kind of information, where you can find and for which use cases you can find this kind of details about the publicity of the machine learning models. We haven't done that yet, of which models will be published, because as we have 7 use cases, 5 of them are using the machine learning. So we can share some parts of the code, as Pablo said, for some of them. Pablo, correct me if I'm wrong about that.
So yes, it's for the moment for this, it mainly depends on the use case owner because they are the one that gave the data and the information. And some of them are okay to share the models and everything. Some want you can only run the machine learning on the platform by API. So you can run it, but you cannot know what the model is. And this depends on the use case. About some are okay to publish it, some no.
Okay, thank you, Pablo, very much. Are there any questions? Because we are closing. If you have, of course, having some still questions about the workflows that you are testing, we can still stay on the line. You can notify us, just stay on the line. We do not close directly, or you can contact us via email. And of course, if you need any further support in the future for different machine learnings that you want to upload in our platform, or the connections you may, and exploration of things that we have on the platform for your work, please don't hesitate to contact us. We are more willing to, we are very happy to help you on that. So if there are no any more, let's say, questions, or we can close the meeting if you agree. I will wait another minute just to make sure that everything, because I know that we understand that the workflow editor it needs some time to run, so you may face something that you would like to notify us. Okay, I think that's it for today. So if someone interested in the next workshops that you're having, because they have a different, let's say, they have developed differently and implemented differently within the platform, it will be very great if you will see you there also. So thank you all for today. It was very grateful to have you here in our workshop.
Thank you, Rory.
Thank you. Thank you all.
Thank you.
Bye.
Thank you.
Thank
Bye.
you.
Thank you.
Bye-bye. Thank you, everyone.
Bye-bye.